Good morning, everyone. Okay, how did the homework go? Any questions from the homework? I'm listening. I'm with you. Please put it on chat. Hi, can you hear me? Yes, okay. Okay, any questions from the homework? Please get started. Remember, even if I'm not physically in the classroom, I expect you all to do the homework. Okay? So questions addressed to you, that's from your homework. Question number one is, suppose I have what's the derivative? Sorry. Suppose I take the integral of f of x dx and I find its derivative. What should I get? Quickly. Okay, Jonah is answering. I want everybody else to pitch in. So I take a function, I find its antiderivative, and then I differentiate it again. What should I get? Absolutely, I should get the function f back. Because by definition, the antiderivative is the function whose derivative is what's inside. And other questions along the same line. If I take, what do I get back? Again, I get the function f because, one more time, by definition, the derivative of that is the integrand. Okay, so this is the relationship that goes between indefinite integral and derivative. Right, so question number two, before we start, is the following. On your homework, I just want to make sure I will look at number two, one of them, part A, for example. And my question was, verify by differentiation. Okay, so I gave you the following: integral of 1 over the square root of 1 plus x squared dx equal to ln of x plus this. Question is, what does this mean? What am I asking you to do? Okay, what am I asking you to do? You guys have done the homework. You should tell me, what did you do to be able to verify that? Are you guys there? Nobody's answering. Okay, how did you do this problem? I took the derivative of the second equation. Okay, so we're going to take the derivative of that, and we have to get 1 over 1 plus x squared. Okay. So yes, we're here. We have no microphone in the classroom. That's what I was afraid of. Can you use at the same time? Can you use the classroom and the your phone at the same time so you guys can talk to me because I need to hear from you. Can you do that? So you can use the classroom, but have your phone so you can answer. Yeah, you can answer your phone because it's hard for me to teach if you guys are not with me. All right. So the idea is to take the derivative of that and show that it's 1 over 1 plus x squared. So let us do it just as a good practice for differentiation. So what's the derivative of this expression? Let's remember that's the inside and ln is the outside. So the derivative is the derivative of the inside times the derivative of the outside, which is 1 over that. And the question is, we have to show that this is 1 over the square root of that. Okay, so let's do this. And this is a simple practice of differentiation. Okay, the derivative here, this is a 1 plus derivative of 1 plus x squared to the power a half. That's the chain rule. So it's 1/2 times 1 plus x squared to the power a half minus 1 times the derivative of the inside, which is 2x. So finally, this is equal to x plus the square root, and this would give me 1 plus 2 and 2 cancel each other out, and this would give me x over the square root of 1 plus x squared. Okay, and remember, you have to convince me that this is 1 over the square root of 1 plus x squared. So how did we do it? How are you able to get here? Anybody did it, and how did I get there? Okay. All right, I hope you guys have done it. So the only way is we have to find some kind of a common denominator in the numerator. So this will give me equal to. So the common denominator here is the square root of 1 plus x squared. So this will give me square root of 1 plus x squared plus x over the square root of 1 plus x squared, and the whole thing divided by x plus the square root of 1 plus x squared. So which will give me the following. Plus x divided by the square root of 1 plus x squared times 1 over x plus that. This and this cancel each other out, and I will be left with 1 over the square root. So we are absolutely correct. All right, so the goal of those problems is to make sure you understand the meaning of indefinite integral as well as review your differentiation, which is crucial, right? So the last thing I want from the homework, and I want your example, is the following. One of the question was that integral of 1 over f of x dx. I mean, there were a lot of questions. A very, very typical mistake that the student here is absolutely false. And the question is, give me an example to show me it is false. Quickly. Were you able to use your phone to answer? Okay. We have an example to show me that this is false. Okay. So I'm telling you it's false. I need an example to convince me it's false. Whoever is capable of communicating, just do it. When we take the derivative of the second, Rihanna, we don't get, okay, that's a good, that's a good reason. So reason one, okay, Rihanna is telling me if we take the derivative of that, okay, we get, I mean, let us not worry about absolute value for now. We get one, use the chain rule. It's the derivative of the outside evaluated at the inside times the derivative of the inside. Absolutely correct. So we don't get 1 over f of x. Correct. Who can give me, very good. Who can give me an example? That's to be convinced. Give me an example to show me that it's false. So that's very good reason why it's false. Who can give me an example? Okay, f of x equal x cubed. All right. Let me take f of x equal x to the power 3. Very good. So let's see. If I evaluate 1 over x cubed the correct way, that's integral of x to the minus 3 dx. It means 1 over minus 3 plus 1, x to the minus 2 plus c, of course, means minus 1 over 2x squared plus c, which is absolutely not ln of x cubed. Okay, so a very common mistake is whenever the student have 1 over f of x, I put ln of f. This is absolutely false. Okay, and these are two very good reasons why it is false. Okay, any questions from your part before we start today's lecture, which is a quick review of the substitution, integration by substitution, which is, as I said, what everybody I've told you, it's the most important integration technique you guys will learn. Right. So integration by substitution. All right. So let us remember what the issue is, which have been. So suppose I take the integral of cosine x dx. Okay. And this is obviously sine x. Okay, we know that. Now, what if I put here cosine x squared dx? The question is this sine x squared plus c? Quickly, true or false? Absolutely false. Because if I differentiate the right plus c, the chain rule always is the issue. It's the cosine x squared times 2x. That's what the chain rule is telling me. So that's absolutely false. So however, if I take the following integral, cosine of x squared times 2x dx. So I totally changed the integral. Basically, I took that piece here. Is this equal to sine x squared? Is this true or false? Plus c, of course. Okay, so if I take the antiderivative of cosine x squared times 2x dx, basically I'm taking this part, do I get sine x squared? And this is absolutely true because the derivative of sine x squared is 2x times cosine x squared. Now, this integral, the one we see, is a very specific type of integral. This integral here, this one, it has the following form. The integral of f of g of x times g prime of x dx. So this integral have this form, f of g times g prime, where f is what? F is the cosine, and g is the inside function, is x squared. Okay, so this type of integral, cosine x squared times 2x dx, has f of g times g prime. That's the outside, and the inside function is the x squared. So it's an inside evaluated, outside evaluated at an inside times the derivative of the inside. Now, to solve those type of integral, we use the techniques of substitution. So let us review a little bit techniques of substitution. So let's go through that. What's the technique of substitution? So the idea is how to evaluate integral of the form f of g of x times g prime of x dx. Very specific type of integral. Okay, all right. So we use this idea of code U substitution, and let's see how it works. So we have this integral. This type of integral. And we see it, we look at it, we see that we have this type. So the way we're going to simplify it, because it's hard always to guess the answers, like we did here, is we introduce a new variable, we call it a u. And we set the new variable to be usually the inside function, or the function whose derivative is part of the integral. So we set u to be the inside function. And then we evaluate the derivative, the regular derivative, g prime. And then we multiply both sides by dx. So you can think of du as delta u. It's a little bit change of u. Think of it as a quantity. And this would be g prime x times dx. So we do this kind of substitution. And then the main thing is that replace, or substitute actually, everything in terms of u. When I mean everything is everything. So we introduce a new variable. So this integral now become the following. This will become the integral of everything in terms of u. The g of x is my u. The g prime of x dx, the g prime of x dx is the du. So the idea is of the substitution is take a relatively complicated integral to make it into a much, much easier integral. Once we reach the stage, we evaluate as a function of u. So we evaluate this integral as a function of u. Okay, so that's really the idea of the substitution. And the problem with substitution is basically to find the g of x, but with practice, it will not be very hard. So the substitution immediately address the difficulty we have with those type of integrals. Instead of having to guess what's happening, we have a very, very systematic way of producing it. So today we're going to do a bunch of problems where we have substitution. So I start with a very basic one, the one we did a minute ago, and then we go to a little bit more complicated one. So let us start. So I will do the first one clearly. Let me start with the following. Cosine x squared times 2x dx, the problem that we guessed it. All right. So this is have exact format. So this is, I have an inside function x squared, and its derivative is part of the integral. So whenever I have like this, I have to introduce a u. And I let my u to be the inside function, the function whose derivative is staring at me. Once we do that, we evaluate the du dx, the derivative, which is 2x. And then we formally multiply by dx both sides. Okay. Now we stop and we go back to the integral. And we do the substitution term by term. All right, so this will become the x squared is u. So this would become the cosine of u. Now, as I said always to my student, you always keep 2i when you're doing those problems, an I on the integral and an I on the du. Now the du is 2x dx, so this piece here is going to be the du. Once you do that, you have a very simple integral in u. You evaluate it. That's the sine of u plus c. You're done integrating. The last step of the process is to put sine x squared and of the problem. And then you check by differentiating the right term and make sure you get the term under the integral. All right, so let us practice several problems. The problem number 2, and you always have to tell me what do you see. So integral of, again, very simple one. Dx. All right, very quickly, do you see an inside function and its derivative as part of the integral? Okay, so what's my inside function here? No, that's not my inside.
Plus x cubed.
Yeah, 1 plus x cubed is my inside. And that's its derivative. Okay, so I can rewrite this. I don't have to. I will just rewrite for the first examples. I'm going to rewrite this as times 3x squared dx. I just flip them around so you can see the derivative and the inside. So my inside is that piece. That's the inside, and that's the derivative. So I'm going to put u to be my inside function. Okay. Then my derivative is 3x squared dx. Now I don't move, 3x squared. Now I multiply formally by dx. I stop and I go back and do the substitution. So this would be equal to 1 plus x cubed. That's the u to the power 5. The 3x squared dx. So that's a straightforward one. This is my du. Now I am practically done. I have a very easy integral in u. So that's going to be 1 over 6 u to 6 plus c. At the end, I go back to x because x is my original variable in this problem. Okay, all right. Questions? Right. Example number 3, we're gonna do the same thing, but a little bit of change, alteration. So suppose I have x times e to the 4x squared dx. Remember, I cannot take the x out. Remember, x is a variable. All right, do you see an inside function? And its derivative almost out. Everybody is telling me 4x squared. Now, the derivative of 4x squared is 8x. Usually, we should never worry about a constant. So if I have the derivative up to a constant, I am in a good shape. So I'm going to put my u to be, so Braden is absolutely correct, the 4x squared. Okay. And then my du is the derivative times the dx. I stop here and go back to my integral. Remember, everything has to be substituted. So I'm going to flip them around because, as I said, I don't have to, but at the beginning times x dx, because that's part of the dA. And now the substitution process. And substitution means everything, and I have to keep looking at both. So this piece easily e to the u. X dx is a bit problematic, because if I look at the du is not x dx, it's 8x dx, but that's not a big deal. 8 is a constant. I can solve for it. So I divide by 8 both sides. And that's good. Will give me 1 over 8 du equal x dx, because everything has to be substituted correctly. So my x dx here is going to become 1 over 8 du. At this stage, 1 over 8 is a constant. I don't really worry about it. To the du. So this would give me an integral in u, which is e to the u. And e to the u is e to the 4x squared plus c. And of the problem. Okay. All right, two more along the same lines. And please ask questions. And for tomorrow, you have to find a way that you guys stay in the classroom, but you can actually work with me, because that's the way the class should go. All right, so let me give you two more problems. Okay, idea. Yeah, thanks, Arthur. All right, ideas. How can we do that? Is there an inside function? What do you think we're going to do with this integral?
Is the inside function 1 plus 4x?
The u? Yep. A lot of times, picking the denominator, always look at the denominator as a u is a very good idea. So I'm going to put the u to be 1 plus 4x. Because this will give me the 1 over u. But let's make sure. And the derivative is 4, and we know a constant is not an issue when we're dealing with those problems. So this will give me du dx is 4. It means the du is 4 dx. I stop at this stage and I start the substitution process. So this will give me, this will go immediately to 1 over u. Dx is problematic. I go here and I solve for dx by dividing by 4 both sides. So this would give me that this piece here is 1 over 4 du. Now 1 over 4 is a constant. We get it out. Du. Okay, which will give me 1 over 4, the natural log of u, plus a constant c. Now we are safe. 1 over 4 ln of absolute value of 1 plus 4x plus c. And of the problem. All right. Okay, example number 3 is the following. Integral of sine x x. Okay, I'll give you a minute to look at it, analyze it, and tell me what do you think should I do. But you have to analyze it and you have to see what's really going on. U equal cosine. Okay, anybody else? Okay, so first let us really understand the tangent secant square. Yeah, I don't know. Yeah, but with this, yeah, that's also would work, but it will work. Arian, you're right, it will work, but if I had 4 here, it won't. So I'm going to stick to Rihanna's approach. Otherwise, you would be right. So let us make sure we all understand why this is the same pattern as the one we had. So this is sine x divided by cosine x to the power 3 dx. Okay, and that's crucial to always see that. And integration by substitution, you really have to start seeing connection within the integral. So if I look at this integral, what connection do I see? So we can rewrite it if you want as sine x times cosine x to the power minus 3. So I'm still writing it, rewriting it to start to see. And now I realize that I have an inside, and this is actually its derivative outside. So we're going to put u to be, as your classmate said, cosine x, which is the inside function. And now the problem will be simplified. The derivative is derivative of that, which is minus the sine times dx. So the idea is we have to see a function's derivative. Now, verbatim, I substitute. Okay. I can rewrite this first as cosine x to the minus 3 times the sine x dx. So I can see verbatim what's happening, and now we do it. Cosine x, this is exactly the u to the minus 3. And the sine x dx, this is, I need sine x dx, so that's the minus du. I can put the minus out. And now I have a very, very simple integral to proceed. So this will give me minus 1 over minus 3 plus 1, which is a minus 2, u to the minus 2 plus c, which will give me 1 over 2 times u squared, which is cosine square x, plus c, and of the problem. All right, so whenever we have, an integral, we always have to look.
Not just joules. It's joules, yeah. It's not a rate of change, total change. The cap J for
Whoever is talking, please mute yourself because I can hear you. Okay? All right. Integral of dx. Idea? Always. First, rewrite it in a way that you guys, like and see connections between what's going on inside the integral. So the main thing is to see connection. What do you see? Do you see any connections between the functions I had? 1 over x and ln. Okay, so I'm going to write it the way Rayana is telling me. 1 over x, 1 over ln. Okay, now all of you, what do you see? You see a function and its derivative.
U would be ln x.
You will have to be ln of x. Why this is a good idea? Because the derivative is actually staring at us. So this is going to give me the du is the 1 over x dx. And now we can proceed. The 1 over x, sorry. I'm going to rewrite it so it will fit the du. Because I know my du. And now this will be the 1 over the u for this piece, and that piece is the du. Okay, now we're done. That's a very simple integral in u, which will give me the ln of u plus c, which means ln of the ln of x plus c. So the whole idea is always you look inside the integral and you ask yourself, do I see a function and its derivative, which is definitely is happening in this case. Right. Right, my last one, which is a little bit not harder, but it requires that you see a little bit more than usual. Suppose I give you sine x over 1 plus cosine square x dx. Again, I want you to stare at this integral. Try to build some kind of a connection. What's really going on? Okay, I'm trying to give you a little bit of a hint, see if it works. U equal cosine again. Yeah, y u equal cosine, we'll do it again. Do I have the derivative of cosine in this problem? Does it show up with me? The derivative for cosine is sine, so it's a very good choice. So we're gonna put the du would be minus sine x times the dx. And let's see if this is a good choice. So this is gonna be written as 1 over 1 plus cosine square x times the sine x dx. So now we're going to put the whole picture again together. This would be 1 over 1 plus u squared. And this would be minus the du. Okay? So this will end up being minus 1 over 1 plus u squared du. So always we try to observe is there a function, is there its derivative. That's really what we go after. So now integral of 1 over 1 plus u squared, as we mentioned yesterday, that's the arctangent of u. It means finally that's minus arctangent of the cosine x plus c and of the problem. Questions? All right, now I'm going to ask you two questions before I go on with, suppose I give you this problem. I don't know, x squared sine x cubed plus 4. Will substitution solve this problem, yes or no? Yes, what will be your u immediately? Immediately.
X plus 4.
That's u plus 4. Because I have its derivative in front of me. Okay, so the substitution really is very limited. You have inside its derivative. If I put, let us say, x instead, here. Do you think substitution will work? substitution will not work, absolutely. So the substitution work, you have to see a function and you have to see its derivative basically in front of you to be able to work, for the substitution to work. Otherwise, it doesn't work. This being said, I'm going to give you two different kind of substitution where I will tell you what the substitution is because it's actually weird, but the idea is to learn how to do it. So special substitution. So my question is, evaluate the following integral. X over, let us say, the square root of 1 minus x dx. Okay. All right. And okay, we stare at this problem. It looks basically impossible to proceed because even if I put u 1 minus x, its derivative is minus 1, which is really doesn't work. All right. However, this being said, I did call it special substitution because these are problem where I will give you the substitution usually, but my goal is to learn how to do it. So I'm going to put u equal 1 minus x. And you're going to tell me, okay, well, it's, it doesn't work. But let's see how I'm going to make it work. So this will give me my du is minus the dx. Am I correct so far? Okay, now I'm going to do the substitution. And this is really what the problem is. Substitution means everything within the integral have to be substituted in terms of u. So how I'm going to do that? Okay, I'm going to do it the following way. Everything in terms of u. My denominator is not a problem. My dx is not a problem. Now I'm left with x. I cannot keep x because substitution means everything in terms of u. So how I'm going to do to solve for x? It's very special substitution, and you will only do it when I tell you to do it, at least at the beginning. Okay, what I'm going to do with this x hanging in there? I have to substitute everything in terms of u. So I go back to my initial u right here. And I said I need to substitute this x in terms of u. So I'm going to solve for it in terms of u. So this will give me x equal 1 minus u. So that's why I call them special type of substitution. So now I'm going to plug it here. I'm going to put 1 minus u. Are you with me so far? Okay, now I solve. Now this is an integral in u that I should be able to do. The minus now can go out and I will be left with 1 minus u over the square root of u du. Okay, now I need to solve this integral. So this is minus the integral of 1 minus u times u to the minus a half du. So it's a very specific type of substitution that is not intuitive. That's why I usually will tell you what to do in those type of problems. So find is equal to, now I need to distribute u to the minus a half minus u to the power, u times, that's 2 to the power 1 times minus a half. 1 minus a half is a half du. So that's, again, we're back to basic at this stage. So this would give me minus the following. Okay. Antiderivative of u to the minus a half is 1 over minus a half plus 1. U to the minus a half plus 1. Minus 1 over a half plus 1. It means 1 over 3 halves. U to the power 3 halves. So finally, I'll get the following. Minus 2 times square root of 1 minus x minus 2/3 1 minus x to the power 3 half plus. Okay, so those type of substitution, as I said, are very different because, of course, we don't have a function, its derivative. But what I like about them is tell us that when we substitute, everything has to be substituted. So we cannot really keep x and u at the same time within an integral. Everything has to become in terms of the new variable. So a last question, a last example along those lines is the following. Again, that's the special type of substitution. The x. All right. We want to integrate this. There are two ways. There is a long, long way. Take 2x plus 1 to the power 4 and expand it. We can do that. But the power 4, I picked a high power because to discourage you from doing this. So what would be another approach to do that? This is again the special substitution. What do you think I'm going to put u to be? The term that I don't want to raise it to a very high power. I'm going to put u to be 2x plus 1, and then I will proceed. The du is the 2 dx. And then verbatim everything. This will be u to the power 4. X squared, oh, x squared is problematic. I have to substitute, solve x for it. So this would give me x equal u minus 1 divided by 2. So this is u minus 1 squared divided by 4. And finally, the dx. I need to solve for the dx. So I have to divide by 2 both sides. And that would give me a half du. So now it becomes slightly easier than before. 4 and 2 are constant. I take them out. U to the 4. Now u minus 1 squared is relatively easy. And now I am back to a very basic kind of integrals. And this would give me 1 over 8 u6 minus 2 u4 times, that's a 5, plus u to the 4 du. And then this would give me 1 over 8, 1 over 7, u to the 7, minus 2 over 6, u to the 6, 1 over 5, u to the 5, plus c. And at the end of the game, we go back to our initial variable, which is my x. One over 5, 2x plus 1 to the power 5. Yeah, it looks complicated, but it's not really very simple, very hard. Okay, any questions? All right, so I will stop here today. Tomorrow we're going to review definite integral. And hopefully very soon, once we review definite integral and Riemann sum, for those, most of you have seen it, so it's good for you to review it. And then we start basically the new material. And a question about the book. Did you guys manage to get the book or not yet? Anybody still have difficulty with the book? I got the book. Great. Anybody else had any difficulty? Okay, great. So please do your homework for tomorrow and make sure you ask questions about it. Any question at the beginning of the lecture, and we find a way so you guys can communicate with me much more because it's easier for me to teach when you guys are really with me. Thanks for those who participated, and I want the rest of you to participate more in the course. Okay, that's it for today. If you have any questions, please let me know. Okay, bye-bye, and I'll see you tomorrow. Bye, guys. on both sides.